Here we have a surface which is actually missing the y variable, which is sort of interesting how that manifests itself in what the surface ends up being. Let's just start with the usual approach. Let's look at the traces. Let's start with the, say, the xy trace. Why not? So I set z equal to 0, and I get x squared equals 4, which says x is plus or minus 2. Now x equals 2 is this line, and x equals negative 2 is this line here. Let's try the YZ trace. That's defined by x equals 0. That gives us z equals 4. So on the z-axis, I go up 1, 2, 3, 4. And I draw this line right here. So the line that I just drew is in the YZ plane, and the first two lines that I drew were in the XY plane. Now let's look at the YZ trace. The XZ trace. Now what's interesting here is that's defined by y equals 0, and there's no y in the equation. So the equation doesn't change, but we are taking this from 3 dimensions down to 2. When we do that, we get a paraboloid, z equals 4 minus x squared. The x-intercepts of the paraboloid are 2 and negative 2. And the vertex is x equals 0, z equals 4. So it's this parabola here. Now what's interesting is if you take a trace parallel to the XZ trace, say the trace y equals 3, the 3 has no bearing on this equation, so you essentially get the same parabola, just in a different plane. The plane y equals 3, so come out 3 units. And I draw the same, let's redraw the axes. That's really bad. Let's try that again. It's parallel to the x. This is parallel, parallel to the z. And I'm going to draw the same parabola. What you actually have is a continuum of parabolas, all the same, running parallel to the y-axis. Let me see if I can shade this in such a way that it looks halfway decent. So here's the top part, curved part. And it comes down. So you have this front half, and then of course there's the back half over here. Kind of looks like a parabolic arch. I would say that's what it is, actually. This is an example of a cylinder parabolic cylinder, in fact, and it runs parallel or along the y-axis. That's always going to be the case when you have an equation in two of the three Cartesian variables x, y, and z representing a surface. The missing variable turns out that the cylinder is going to run along or run parallel to that missing variable's axis.